AI, as we've seen so far this morning, is a powerful tool, but it's critical that we design AI systems from what I term the user, community, and society level. And if we design AI systems in this way, we're likely to have a more positive societal impact. I've been trying to work on this, defining this new model of AI design for the last year, and today I hope to make these ideas clearer as I speak about the need for a more human-centric view of artificial intelligence. So as you all know, AI is taking the world by storm in many areas, from scientific discovery through things like AlphaFold to natural language processing in the translation tools that many of us use every day, to agents like 챗지피티 that are based on large foundation models that are taking everyone's world by storm. But even in areas like fashion design, where AI is being used to plan what fashions are going to be popular in the future and how to optimize the supply chain. AI is even starting to work in areas like robotics, though maybe not yet in this social aspect as you see here. But the place that AI is most common in our daily lives and making impact is in manipulating our social network feeds, causing people to feel bad, or causing people to be angry and deceived and outraged, even upending democracies all over the world. We've also seen AI helping judges to set bail or sentencing for suspected criminals in a way that is biased by race, as has been shown here in studies of the Compass program in the US. And these are some of the reasons that at Stanford we founded the Institute for Human-Centered AI almost 4 years ago, in anticipation of many of these problems that we're seeing today. Maybe these problems are happening sooner than we anticipated when we did this. First, that AI should be inspired by human intelligence. The human brain remains the most sophisticated device in the known universe, and we should strive to learn all we can from its nature. So we want to be inspired by the human brain in terms of neuroscience and cognitive and behavioral science as we explore what are the AI technologies that will follow beyond the deep learning revolution that we've seen making the advances of today. The second principle we've had is a real concern for AI's impact on human society. This technology is simply too potent to consider its effects after the fact. This compels us to explore ethical implications and societal impact before, during, and after the development of AI systems. And then finally, we should use AI to augment, not replace, human capabilities. Now, it's inevitable that AI will shape or reshape significant swaths of the global workforce. And we should prepare ourselves for that upheaval in coming generations, and we should do so better than we did with globalization previously. But we also believe with the proper guidance, we should aim our design of AI systems in ways that enhance the qualities that make us human, rather than focusing on replacement. Now, because of the negative societal impacts that were mentioned in the previous talk, and as I've mentioned here, we've seen a proliferation of AI for good projects, initiatives, and institutes. And there are two main ways that I see many of these efforts going. The first type of initiative is often made up of social scientists and journalists who notice and critique the potential or real harms of AI. And this is quite useful, but that doesn't help engineers and designers apply AI in positive ways. It might avoid some of the problems after the fact, but we'd like to get to these warnings earlier. How do we proactively design AI to avoid these issues? The second type of effort which is both more common and often fails, is when technologists try to go it alone. Typically, AI experts see an important societal impact area like health, and they apply AI naively so that it doesn't end up working in practice. This has happened repeatedly, but has occurred acutely in short-term crises like COVID. It's also happened repeatedly over the long term. So, as Yoon Song-yi mentioned in her talk, in 2016, Turing Award winner Jeff Hinton said, "We should stop training radiologists now, as AI will easily surpass humans within 5 years." This prediction has not worked out. Luckily, we kept training radiologists. It hasn't worked out in AI in radiology, not in AI in skin cancer detection, and not in AI in several other areas. Now, this is often due to differences between the ideal data sets on which researchers train and test their algorithms, and then the messiness of the data found in real-world clinical situations in hospitals and clinics. But I would claim, even worse, often these researchers don't even solve the right problems. So, for example, instead of trying to replace radiologists, we might want to have AI systems working in tandem with radiologists to make the technology more useful, augment the radiologist's capabilities rather than replace them. My Stanford radiology and AI colleague, Kurt Langholtz, writes in one of his papers, quote, "Will AI replace radiologists is the wrong question." Instead, he wrote, "The right answer is radiologists who use AI will replace radiologists who don't." The bigger problem, as I see it, is we don't actually know how to design AI systems to have positive human impacts. And I believe there's a better way to design AI for positive human impact. The better way is what I term human-centered AI. How do we get these positive outcomes from AI? That is, what would it have taken to have avoided the negative outcomes from the Compass's AI-assisted sentencing program? To avoid these outcomes, we must design and analyze these systems at the 3 levels I mentioned in the intro in conjunction. So in terms of the user, the community, and society. I believe that if you do, you will create technology that has a better chance of making a positive impact. So what do I mean by human-centered AI in these 3 levels of analysis? First, human-centered AI is about the scope of who we study to find our problems, develop our solutions, and evaluate our resulting systems. To do this, we first need to start with a user-centered process. That is, we need to integrate well-known techniques from human-computer interaction and design that account for the needs and abilities of end users of computing systems early and often, and rapidly iterate and improve a design through rigorous testing. But I would claim that even this is not enough. As has been illustrated by some of the harmful examples I mentioned previously, we can't only design around the user. That would be like designing that sentencing system just for the judge. We could create a nice user interface so that he could understand the data, but that would ignore some of the underlying systemic issues. It would ignore the community that the system impacts, the people who are accused, their families, their lawyers. We need to understand the issues of different communities they come from and the structural barriers they face. For example, racism, before we can appropriately design that sentencing system. Maybe some of the people that we meet at that community level would become users and should be included at that user-centered level of design. But even that is not enough. We also need to understand the impacts and what the impacts are on society at large. What does it mean to have a large percentage of African American males in prison in the US? Or a large percentage of people who are caught using illegal drugs? These issues have immense societal costs. We need to be able to forecast what might happen if this software becomes ubiquitous and designed to mediate for potential societal impacts. Now, I'm not saying this is easy. In fact, it's very hard, especially for computer scientists and technologists. That's why we need true interdisciplinary teams. So not only technologists and AI experts, but also experts from design, experts from the social sciences and humanities, and domain experts depending on the area. So experts in fields such as medicine, law, or environmental science. And these experts must be true partners on AI projects from the start, rather than added near the end to investigate possible harms.